In 2003, astronomers discovered an object orbiting the Sun at a distance so extreme that it defied explanation. The object was Sedna, a body roughly the size of Ceres, moving on an orbit so elongated that it takes 11,400 years to complete a single trip around the Sun. At its closest approach, Sedna never comes closer than 76 astronomical units from the Sun. That is more than twice the distance of Neptune. At its farthest, it swings out to nearly 1,000 astronomical units, deep into a region of the solar system where nothing should exist in a stable orbit. Neptune's gravity cannot reach it. The Sun's influence at that distance is faint. Sedna is detached from the rest of the solar system, moving on a path that nothing in our current model of planetary formation can produce. Something put it there, and whatever that something is, it has not been found. In 2014, a second object was discovered on a similar orbit. 2012 VP-113 has a perihelion distance of 80 astronomical units, even farther from Neptune than Sedna. Its orbit is tilted and elongated in a way that mirrors Sedna's. Two objects discovered a decade apart are on orbits that share the same basic geometry. The odds of that happening by random chance are low. The odds of it happening because something is gravitationally shepherding those orbits are much higher. The question became, what is doing the shepherding? In 2016, Konstantin Batygin and Mike Brown at Caltech published a paper that changed the conversation. They proposed that the orbital clustering of extreme trans-Neptunian objects could be explained by the existence of a massive unseen planet orbiting far beyond Neptune. They called it Planet 9. Their model predicted a body roughly 5 to 10 times the mass of Earth, on an orbit with a semi-major axis of 400 to 800 astronomical units, and a perihelion of about 300 astronomical units. A planet that far from the Sun would be extraordinarily dim, reflecting almost no sunlight, moving so slowly against the background stars that it could easily be mistaken for a distant galaxy or ignored entirely in survey data. But its gravitational fingerprint, they argued, was unmistakable. The clustered orbits, the tilted orbital planes, the existence of objects on retrograde paths that should not be possible without an external influence, all of it pointed to one thing: a planet mass object that has been shaping the outer solar system for billions of years without ever being seen. The model was elegant. It explained multiple anomalies simultaneously, and it predicted observable signatures that could be tested. And in the 9 years since the hypothesis was published, despite some of the most powerful telescopes on Earth searching for it, Planet 9 has not been found. The Subaru Telescope on Mauna Kea, one of the few instruments capable of detecting an object this faint at that distance, has surveyed the highest probability regions of the sky identified by Batygin and Brown's orbital constraints. No detections have been reported. The Vera C. Rubin Observatory in Chile achieved first light in June 2025 and began full survey operations later that year. Its legacy survey of space and time is designed to map the entire visible sky repeatedly over a decade, cataloging moving objects down to extremely faint magnitudes. If Planet 9 exists within the predicted orbital range and has the predicted brightness, Rubin should find it. As of early 2026, it has not. And then, in July 2025, the mystery got stranger. The Subaru Telescope discovered a fourth sednoid, an object designated 2023 KQ-14, nicknamed ammonite. Sednoids are the rarest class of objects in the solar system. Bodies with perihelia so distant that they are completely detached from Neptune's gravitational influence. Before ammonite, only 3 were known: Sedna 2012, VP-113, and 2015 TG-387. What makes ammonite significant is that its longitude of perihelion, the direction in which its closest approach to the Sun is oriented, lies opposite to that of the previously known sednoids. It fills a gap in the orbital distribution that the Planet 9 model predicted should be empty, or at least populated differently. The discovery does not disprove Planet 9, but it complicates the picture considerably. If Planet 9 is real, Ammonite's orbit requires the planet to be on a more distant orbit than earlier estimates suggested, roughly 500 astronomical units from the Sun, pushing it to the faintest, hardest-to-detect end of the search space. Some astronomers are not convinced the clustering is real at all. Samantha Lawler at the University of Regina has argued that the apparent alignment of distant orbits may be an artifact of observational bias, a product of where and when telescopes have looked, rather than a genuine physical signal. When her team corrected for these biases, they found the orbital distribution to be consistent with randomness. Another recently discovered trans-Neptunian object, 2017 of 201, was found on an orbit that does not align with the predicted clustering, further weakening the statistical case. The debate is unresolved. The clustering might be real and caused by a planet we have not found. It might be real and caused by something else entirely, or it might not be real at all. But the gravitational anomalies extend beyond orbital clustering. The solar system contains objects on orbits so strange that no current model can fully account for them. There are trans-Neptunian objects on highly inclined paths, some nearly perpendicular to the plane of the solar system, others moving in retrograde motion, orbiting the Sun in the opposite direction from everything else. Battigan and Brown simulations showed that Planet 9's gravity could produce these orbits by slowly torquing the paths of scattered disk objects over billions of years, flipping them into extreme inclinations. If Planet 9 doesn't exist, something else is doing this, and nobody has proposed a compelling alternative that explains all the anomalies simultaneously. There is another possibility that has been gaining attention, and it is stranger than a missing planet. Recent research has demonstrated that objects from interstellar space can be permanently captured by the Sun's gravitational pull. A study by Edward Belbruno at Yeshiva University and James Green at NASA described a mechanism called permanent weak capture, in which rogue planets, asteroids, or comets drifting through interstellar space can be drawn into stable orbits around the Sun through the combined gravitational influence of the Sun and the Milky Way galaxy. The capture region exhibits a fractal-like structure, a chaotic but stable pattern that ensures captured objects remain bound to the Sun indefinitely without colliding with it. The implications are significant. There may be billions or trillions of rogue planets wandering the Milky Way, ejected from their original star systems by gravitational interactions. If even a fraction of these pass through the Sun's capture region, the outer solar system could contain objects that didn't form here, objects that originated in other star systems around other suns in other parts of the galaxy. The gravitational influence of a captured rogue planet, even a small one, could warp the orbits of nearby trans-Neptunian objects in ways that mimic the Planet 9's signal. Without requiring a planet that formed in place, the anomaly might not be a missing planet. It might be an intruder. In January 2026, astronomers announced the first ever direct measurement of both the mass and distance of a rogue planet. A Saturn mass object, roughly 10,000 light-years from Earth, detected through gravitational microlensing. The discovery confirmed that rogue planets of significant mass exist and are detectable. NASA's Nancy Grace Roman Space Telescope, expected to launch in 2026, will scan the sky in infrared light 1,000 times faster than Hubble, specifically designed to detect faint objects that emit almost no light of their own. If there are captured rogue planets hiding in the outer solar system, Roman may be the first instrument capable of finding them. Here is what we know. Something is shaping the orbits of the most distant objects in the solar system. The orbits are clustered, tilted, and in some cases reversed in a pattern that defies random chance. The leading explanation is a planet 5 to 10 times the mass of Earth, orbiting at 400 to 800 astronomical units. After nearly a decade of searching, that planet has not been found. The discovery of Ammonite in 2025 complicated the model. The Vera Rubin Observatory is scanning the sky right now, and so far, nothing. Some astronomers believe the clustering is a statistical artifact. Others believe the cause is something we have not imagined yet: a captured rogue, a primordial black hole, or a disk of material too diffuse to detect individually, but massive enough in aggregate to shape orbits at the edge of the solar system. The primordial black hole theory is the most unsettling of all. In 2019, physicists Jakob Schultz and James Unwin proposed that the gravitational signature attributed to Planet 9 could instead be caused by a black hole formed in the first second after the Big Bang. Primordial black holes are theoretical objects, tiny compared to the stellar black holes created by dying stars, but incredibly dense. A primordial black hole with a mass of 5 to 10 Earths would be roughly the size of a baseball. It would emit almost no radiation. It would be invisible to every telescope ever built. And it would produce exactly the same gravitational fingerprint as a planet of equivalent mass. You cannot distinguish between a planet and a primordial black hole using orbital dynamics alone. The orbits of the sednoids would look identical in either case. The only way to tell the difference would be to detect the faint halo of radiation produced as the black hole annihilates dark matter particles in its vicinity. A signal so weak that no current instrument can measure it at the distances involved. If there is a primordial black hole orbiting the Sun at 500 astronomical units, it has been there since the formation of the solar system. It would predate every planet, every moon, every asteroid. It would be older than the Sun itself, a relic of the first moments of the universe, quietly warping the outermost orbits of the solar system for 4.6 billion years, without anyone knowing it was there. The math works, the physics allows it, and nobody can rule it out. Something is hiding out there. We can see its fingerprints on the orbits of objects billions of miles from the Sun. We can model its mass, constrain its orbit, predict where it should be. But every time we point a telescope at the place the math says to look, the sky is empty. The Vera Rubin Observatory is scanning the predicted search region right now, frame by frame, night after night. If Planet 9 is a planet, Rubin will likely find it within the next few years. If it is not a planet, if it is something smaller, darker, and stranger, then the search could go on for decades, and the gravitational ghost at the edge of the solar system will remain exactly what it is today, the most compelling evidence for something we cannot see, cannot name, and cannot explain. If you want to keep exploring what the universe is really doing, subscribe. I will see you in the next one.